Okay guys, in this chapter we're going to talk about the equations of circles. Now, up until now, if you've only been watching King or Review, or if this is sort of where you are in your geometry class, up until now you've probably had experience with a couple of different types of graphs. You have experience with lines, of course. We learned that in algebra. You also have experience with parabolas, and so I think probably the first time, I remember I learned parabolas, it was quite shocking to see, like, oh, how can you actually graph something that's curved? But in fact, there are relationships between x and y that do show how that's true. And then I think, when I had friends who were older than me, and they were talking about the equations of circles and ellipses and all these other crazy things, I was really, kind of like, how in the world is it possible that you can take an equation and out of that equation you can get a circle? And so I was really quite amazed, but really I just want to, hopefully through this video, show you where the equation comes from and show you that it's not that scary. Okay, it's not that scary, and so it's really just something that you're probably all very familiar with, and that's Pythagorean Theorem. So let's start over here. Let's say we have a circle, and our circle is centered at the origin. Of course, it's very nice to be centered at the origin first. So we're centered at the origin, and we have a point, this is the radius of the circle, r. We also have the point, this is going to be our x value, our y value, and this point is going to be x and y. And so what's nice whenever you're trying to derive the equations of anything is to make everything very general. Okay, so notice I can move this point anywhere. I can actually make the radius bigger or smaller. If I was at a computer on certain software, I could move this point, make it as big or as small as I wanted, and all of these things would be true. R would always be R, x might become negative, y might become negative, and here both x and y are negative, right? But then that would be reflected in this situation. And no matter whether this is negative or positive, it doesn't really change the equation. And so I'll explain that in a moment here. But basically, if we make a right triangle and we use what we know about Pythagorean theorem, then we know that the Pythagorean theorem says the sum of the legs squared equals the hypotenuse squared. So that means x squared plus y squared is going to equal r squared. Okay, and even though this doesn't look like a formula, even though this is not like y equals something, then actually this is the equation of a circle that is centered at the origin. Okay, so this is the standard form of the equation of a circle centered at 0, 0. So this is a circle centered at 0, 0. Now I want to get back to what I was talking about, why it doesn't matter if x and y are negative. The reason it doesn't matter if x becomes negative is because a negative times a negative is going to be positive, and it doesn't matter if y becomes negative because a negative times a negative is positive, and so that's always going to equal positive. So this is a nice general formula for any place, whether the radius is small, whether it's big. Anytime this is centered at 0, 0, this will be our equation. Now, coming up here, what if it's not centered at 0, 0? What if it's centered at, mathematicians like to use the letters h and k. Okay. Well, what we're going to do is we're going to set up the same triangle. Okay, and we're going to do the exact same logic. It's just going to be a little bit more difficult. Okay. We're going to use the distance formula here, and we know that the distance between two lines is d equals, I'm just going to write the distance formula out, root x1 minus x2 squared plus y1 minus y2 squared. Okay, so that's our distance formula. So we know because a radius is always the same distance. The radius will never change no matter where x and y are. If our center is here, x and y will always be the same distance. So this equation would represent all the points on this, that are equidistant from that one point, which is our definition of a circle. Okay, the points that are equidistant from another point, which is the center. So distance equals, well, we just plug in, what we know. It's going to be root, let's see here. Let's call this point 1 and this point, point 2. So this is point 1 and point 2. So what I've done is x minus h squared plus y minus k squared. And that's it. That's it. Instead of d, we're going to replace this with r. Okay, r. So this will be r. r equals root x minus h squared plus y minus k squared. Now, you should notice that all of this is in common, right? Like this value is x minus h. This value of that line is y minus k. And so you see that distance formula, Pythagorean theorem, equation of circles, all of those are very interconnected, and they all stem from the same concept. That's why we see this sort of same pattern. Wherever you see a pattern where you see a root and a square, that is a dead giveaway that came from the Pythagorean theorem somewhere. And so you see this Pythagorean theorem pop up. Equations of circles you'll get to in geometry, you'll deal with more in algebra 2. So it pops up in algebra 2. And you see Pythagorean popping up all around mathematics, and it's really quite interesting. But even though this looks a little bit ugly, we still have to reduce this to look like this equation. So if we just square both sides, we get r squared equals x minus h squared plus y minus k squared. And that's going to be the equation of a circle centered at any point h k. Okay, so any point hk. So in the next video, we're going to look at some examples, and hopefully this will become a little more clear. But for now, this is the two equations that we'll primarily be working with. Thanks for watching.